Today we're going to go over what a composition function is. This is essentially taking two functions and composing it to create one new function. So you'll generally see this notated as fog, and this can also be written as f of g of x. I personally like seeing it written as the second one because you can really visualize g of x being inputted into the function of f of x, whereas this one we see that it's the second function. So it's best to see this in example form. So let's say that f of x is equal to x squared minus 1, and g of x is equal to x plus 5. So if we wanted to go ahead and find out what f of g of x is, we would say, let's plug in g of x into every x position of f of x. So we would see that we would have x plus 5 squared minus 1, because we took g of x and plugged it into the only x position, which is this x squared. So if we were to factor that out, we would see that that is equal to x squared plus 10x plus 25 minus 1, which is equal to x squared plus 10x plus 24. And this is what g of f of x, f of g of x is going to equal. We got a brand new function. If we were to want to do it the opposite way, let's say we wanted to find that's also the same thing of g of f of x we would say, let's go ahead and insert the function f of x in every x position of g of x. So we see that we would get, we're going to plug in f of x here, which is x squared minus 1, and plus 5. So we plugged in f of x into every x position of g of x, and this is just going to equal x squared minus 1 plus 5, which is x squared plus 4. So it depends on which function you're plugging into the other function. We see we got two brand new functions here if we took f of g of x or g of f of x. So that's what a composition function is.